So, terminating, recurring, and rounding decimals. We're going to be continuing on with our whole fractions, decimals, and percentages lesson topics that we're talking about. And today is focusing on the decimals part of that. If we have a fraction and we divide the numerator by the denominator, will there be enough space? Oh, just. So if we have a fraction and divide the numerator by the denominator, so let's say we have a fraction 2 over 7, and then we divide 2 by 7, it's going to get us a decimal approximation of the fraction. Decimal approximation of the fraction. Now, I say approximation because decimals aren't exact, right? They're where things should be. Some decimals are very accurate. 0.5 is exactly a half. 0.8 is exactly 4 over 5. But sometimes you are just talking about how close you can get to a number, whereas fractions is the exact number of it. So we just need to be careful on those ones. So there are two, we'll talk about a few types of decimals. So let's say we have a half, and I just said that's the same as writing 0 over 5. Oh, sorry, 0.5. So 0.5 and a half are similar, they're the same thing. Does anyone know the decimal approximation of a third? J. Yeah, 0.3333, and I'll keep going on, and I'll just say the point you said for a sec. And then we've got, let's say, 1 over 7. And I'm not expecting you guys to know what 1 over 7 is because it's not a nice number. But it's going to be 0.142857, and it just keeps going.
Doesn't it repeat the same?
Not necessarily. Okay. So a half is the same as 0.5. We notice that it is exactly 0.5. There's nothing after it. We call this a terminating decimal. A terminating decimal because it stops. Okay, it stopped. It doesn't keep going on. Jay, what's that fancy word with an R that you said to describe that? Recurring. Recurring is when there is a repeated pattern in the decimal. So it could be one number, it could be two number, it could be 3. But since it's just 3 over and over, it is a recurring decimal. And I'll explain a bit more what a recurring decimal is later on, but we just want to get a bit of an idea of it first. So this is a recurring decimal, and 1 over 7, does anyone know what we'd call that? An annoying number, or a decimal. It's just a normal decimal. Okay, just a normal decimal. There's no special word, there's no pattern we can expect. This is a decimal, not this a decimal. There is, I'll get into it later. So this is just a decimal. So just be aware of what you can categorize them and the different types. You have a terminating, a recurring, and then just regular decimals that there is no pattern, it just keeps going. A terminating decimal. So a terminating decimal has a finite number of decimal places. Does anyone know when I say that word finite? I wrote finite twice. Sorry.
It will not keep going.
It won't keep going. Or Leo, what were you going to say?
Well, I was just going to say it ends.
Yeah, it ends. It's a set number, right? Like, there is a finite number of students in this room because there is only a certain number of students in this room. I can't have a third of a student unless I'm a bit of a cannibal, and I'm not about that life. Okay? But...
Oh, yeah.
Stop with the Brooklyn Nine-Nine references, okay? So there's a certain number, it is definite, it is a finite. For example, 0.625, that is a terminating decimal. 0.4, that is a terminating decimal because there is a finite number of spaces. There is only a certain number of spaces. It stops. A recurring or repeating decimal, the proper word is recurring, but you could also have it referenced as a repeating decimal because that kind of explains it a bit better. It repeats itself. So a repeating decimal has an infinite number of decimal places. So it has an infinite number of decimal places with a repeating pattern. So a recurring or repeating decimal has an infinite number of decimal places with a repeating pattern. So let's just say we've got a recurring decimal of 0.55555 and so on. Well, we can rewrite that using one of the following, okay? We can have 0.5 with a dot above it, or we could have 0.5 with a line above it. You can use both. Both are mathematically accepted. So you need to just be careful sometimes with the way you write it. Then we could also have 0.34 1, 2, 4, 1, 2, 4, 1, 2. And now I have to be really careful in how I write this one. Does anyone have any ideas? Leo?
Alright, so you write 0.3.
Yep.
And then you write 412 with a line over it.
Yep. So, what Leo's just said, I can write the 0.3. The 3 does not repeat. The 3 is a number on its own, so that doesn't need any of that notation above the number. But 412, that repeats itself over and over and over and over again, as we can see from that pattern. So the 412 is what repeats, so that is where we draw our line. You can also use the dots to represent this. You draw a dot above 4. You draw a dot above 2. You don't need one above the 1. I don't like using dots when it's more than one number. I think it's way too confusing. Draw the line if it's more than one number. If it's one number, just use the dot. You're never going to get it wrong if you write it that way. Tashara.
What if it's only 4 and 2, not 1?
It's written that way because we can imagine a sort of line in between them.
Okay, but what if there's not 1?
If there's not one, if it's just 3, 4, 2, 4, 2, 4, 2.
No, there's 4 and 2. But there's still 1 is in there.
So, for example, 3, 4, 1.
I'm confused by what you mean.
4,
Never
2,
mind.
2, and 4, 3.
Then it wouldn't be a repeating pattern. Jay.
Let's say the number is like really long.
Yep.
But it does repeat, but you can't get far enough to see when it repeats.
Then you wouldn't be expected to. Like, we're not going to get you like to trick you and have like a repeating digit of like 13 numbers. It'll be clear if it's a recurring decimal or not, and you won't be expected to know if it's a huge recurring decimal if it's more than those places.
How far do you want us to write it, and how many numbers do you want us to write until we stop? Because we don't want to write like 200 numbers.
Like that's fine. You know, as long like 3. If it's more than one number, let's say 3. If it's one number, let's say 5. Just show. Let's just have that as a base rule. Tashara?
If you round it, would you still need that little line on top? The recurring sign?
If you round it, no, because if you round it, you're taking away that pattern. But while we've come up, rounding decimals. So rounding decimals involves approximating a decimal number to fewer decimal places. We good over there? Yeah?
Sound okay.
Rounding decimals involves approximating a decimal to fewer decimal places. Let's say we want to round to 3 DPs. When I say that, I just mean decimal places. Just be aware of what we're talking about here. Is anyone else really hot?
Yes.
Cool.
Can we turn on a negative factor, please?
Okay. Fans are on. Aircon's on.
Oh, that feels so much better.
Let's say I have the number 51.34721. Now, they're really quick. Whatever.
Oh, that feels so good.
Jay, cut it out, dude.
Sorry.
Hey. So we want to round it to 3 decimal places. So a technique that I like, you go 3, 4, 7, and then you draw a line. Okay? It says 3 decimal places, so you go 3 decimal places and you draw a line. We can think of that line as a door, kind of. Okay? Yeah. So we draw a door. And see what's behind it. So we have our door. What is behind my door? The number 2 is behind my door. If it's the number 2, do I round up or do I round down? I round down. So that means that it's going to be 51.347. Because behind my door is the number 2, and I round down if it's a 2. Kate. We do not care about the 1. It is just the one number that's behind the door that we care about.
Wait, why is the 2 gone? Wouldn't it be...
Because we've rounded down
I never...
to 3 decimal places. That's why we draw our line there at 3, because all we care about is what's on the left of that blue line.
But why... Can't you round 21 to 20?
No.
It's because we're rounding it to the 3rd decimal place.
We're rounding it to the 3rd decimal place. That is just accounting for this number here.
Oh yeah, so it turns into 70. Like the 72. Oh yeah,
Yeah,
okay.
yeah.
I got confused there.
So, Don't make me move you 3, 'cause I'm getting over it. If the number behind the door is 4 or lower, so if we're 4 or 3 or 2 or 1 or 0, we round down. We round the number down, which would be this example that we've got up there, that 51.347. That's when we round down.
Does 4 include?
Yes, including 4. If the number behind the door is 5 or above, we round up. So if the number is 4 or lower, round down. If the number is 5 or up, we round up. So now let's just go through some examples of the following.
Is there a worksheet?
No, just text. So we want to show the following fractions.
No, it's not. It's perfect.
It's really not. I have medical diagnoses.
So I want to show the following as a decimal. If I have 2 over 3, what I would do is I would divide 2 by 3. So 2 divided by 3, which is equal to 0.6666, and it will keep going on.
Can we put that in the calculator? How we divide 2 by 6?
Yeah, no, you can have a calc.
So
Yeah.
you would just write 0.6 recurring.
You would write 0.6 recurring. Okay? You could do that in 2 ways. You could have it with the dot or the line. Again, just as a rule of thumb, I like the dot for one number and the line for multiple.
I like the line.
Okay? But it's really up to you.
Does it matter?
It doesn't matter. Both are correct.
Why is there 2? I don't get why there's 2.
Because mathematicians, when they figure this out, they're like, you know what? Some people don't like dots.
So you put a line. Why
Yeah.
don't you put a star?
What if you put a golf? A dot or a line?
3 and 5 over 7.
Who invented this?
Now I need to try and figure out the decimal approximation of 3 and 5 over 7. Well, if I write 3, that's exact, right? That's the number. We want to split them up. So it's actually 3 plus 5 over 7. We just care about that 5 over 7 part, okay? We don't actually want to change the 3 in any way because it's already a number. So that becomes 3 plus 5 divided by 7. And again, you guys aren't expected to know that. But it goes to 3 plus 0.71428571428 and so on.
It's the answer. Can I say the answer?
Yes, say the answer, Maddie.
3.714285.
Yes. And what do you write above it? What do you write above it? The line. Starting at 7, finishing at 5. with the line above the rest. Another way you could write it is the 2 dots, 1 dot being above 7, 1 dot being about 5. But again, it's not that helpful because I think the line is much clearer to show that is what's going to repeat. Not going to mark you down if you use the dots. I'll probably just be like, cross, sad face, why didn't you do the line? But it is right, you know. Next one. And this is the last set of examples, guys, so just bear with me for a little longer, sorry. So I want to round the following to 4 decimal places. Guys, settle down. Again, draw my door. I go 1, 2, 3, 4. Then I draw the door. Jay, what's behind my door?
9.
So what do we do?
Round up.
It's 5 or above because it's 9, so we round up. So this number now becomes 15.3573. Because it's 9, we round that number up. B. 4.8619508. Now, I'm rounding to 4 decimal places. So, Sean, where should I be drawing that door there? Behind what number? 9. 9 is my 4th decimal spot. So, I draw the door in there behind my 9. Open the door, and what's behind it, Cynthia? 5. So, if it's a 5, do I round up or do I round down, guys? I round up. So, since it's a 5, I round up. And it's going to be 4.8620.
Why 20?
Okay? Exactly. So I'll just hop skip this a little bit. What this is actually doing is it does it like this. So it's 4.861. And then we've got a 10 because we round up 9 to 10. Well, obviously you can't have the number 10 because we need it as a single digit. So you give 1 to the next number. So it becomes 4.8620. It is absolutely important that you put that 0 at the end. We know that so we know that 4.862 and 4.8620 are the same value, but since the question says raised to 4 decimal places, you need to include that 4th decimal spot because the question says 4 decimal places. If you just wrote 4.862, you'd get it wrong. Lastly, 8.17340012. Sahara, where do I draw my door? After the 4. Bree, what's behind the door? So do I round up or down?
Down.
I round down.
Wouldn't it stay the same?
Yeah.
Get the 1, 2 out.
So because that's a 0, we round down. And we're left with that.
Why do we really ignore the numbers?
What, Bree?
Why do we round just to show like instead of just having a bigger one to show it? Yeah.
It's so we can say like it's closest to this, right? So let's say you wanted to round to the nearest 10 and you have 76. Well, is that closer to 80 or is it closer to 70?
80.
It's closer to 80, so we round up. It's just us being lazy and saying what's its closest to. Are there any questions?
No.
Queries?
No.
Okay, for those listening at home, I will put the questions up at the top of the OneNote page, so have a look there after. No, you can. I think Charlie can handle it on her own, but you can tell her later if you want. Otherwise,